1.7 Inverse Functions. In this section, we'll determine if two functions are inverses, find or evaluate the inverse of a function, find function values in inverse functions from a graph, and given the graph of a function, graph its inverse. The inverse of a function is a function that reverses or undoes the function. For example, if a function adds 2 to every input, then the inverse is the function that would, the opposite of adding 2, would be subtract 2. Graphically, when we think about a function and its inverse, we're going to input a number x into the function, and then that output, f of x, gets put into the inverse function, and out comes the original value. So if you put in a number to a function and its inverse, you get out the same value. Now there's a symbol for the inverse of a function, and the symbol for the inverse of a function looks like this, f inverse of x. So it's really important that you note that this -1 here is not an exponent. Instead, when it's used with a function, what it means is the function's inverse. So let's do an example. So for example, the one we just did adds 2 and subtracts 2. These operations are inverses. So for example, if we put in the number 5, if we add 2, out comes the number 7, put that into the inverse function, subtract 2, and you get the original input back. So when you apply the function and then its inverse, you get the original value back. So the inverse of a function is really the function that just reverses or undoes the function. Does every function have an inverse? Well, in order to ask if every function has an inverse, the question is, will there always be a way to undo a function? Is there ever a case where you would put in a number to an operation and then not be able to undo it? That's something that we're going to explore. So to verify first that two functions f and g are inverses, what we need to check is that one undoes the other. For example, if you apply f to a function and then apply g to that function, that result should give us x, the original function value. And if you apply g to a function and then apply f to that result, you should also get x. So to make sure that the function undoes the other function. Usually what I do is I look at a specific case first to see if it's possible that the answer is yes, and then if it is, then I'll show it in the general case. So here's an example. Our f of x equal to 1 over x plus 2 and g of x equal 1 over x minus 2 inverses. Well, to investigate this, I'm going to look at a specific value. So I'm going to use, for example, x is equal to 1. And you could use any value for x that you wanted. All right, let's first start applying f of x. F of 1 would be equal to 1 over 1 plus 2, or in other words, 1/3. So here's the idea. Sometimes I like to draw it out in pictures. So here's function f, and f is equal to 1 over x plus 2. And here's function g. G is equal to 1 over x minus 2. And the number I've just put in is 1. And what I've gotten out is a 1/3. Now we're going to put this into function g, and the question is, what am I going to get out? Am I going to get out the same thing that I put in? If I do, then it's possible that these are inverses. If I don't, then these functions cannot be inverses. So let's find out what g of 1/3 is. G of 1/3 would be equal to 1 over 1/3, in other words, the reciprocal of a third, minus 2. The reciprocal of a third is 3, so 3 minus 2, oh, that's 1. I put in a 1, I got out a 1. So it's very possible that these two functions are inverses. Since it's possible, now what I need to do is I need to show that they are inverses using the general case. Okay, so let's give that a try. So f of x is equal to 1 over x plus 2. So if I put in an x, out comes 1 over x plus 2. Now what I need to do is put that into g. So that would be 1 over x plus 2 minus 2. Now don't let this expression intimidate you. This is just the reciprocal of 1 over x plus 2. And the reciprocal of that is just x plus 2. So this is just equal to x plus 2. So we have x plus 2 minus 2, or in other words, x. So f of x, when we put in an x into f of x and then apply g of x, we got out an x. So the answer is yes, f and g are inverses. So just to recap, to determine if two functions are inverses, one thing that's sometimes helpful is to think of a specific value. So I tried a specific value, and I put it into f first and got 1/3 for an answer, and then put that answer into g and got my original number back. And so it was possible that f and g are inverses. If I hadn't gotten the original number back, then I wouldn't have had to do any of this other work, because the answer would have been, no, they're not inverses. But now that I think that they might be inverses, I should see if I can show it for the general case. Like I showed it was true for x is equal to 1. Can I show it's true for all x's? So if you put an x into f of x, you get out 1 over x plus 2. And then we took 1 over x plus 2 and we put it into function g. That was this work right here. And if we put it into function g and we simplified it, we had the reciprocal of 1 over x plus 2, which is x plus 2, minus 2, which gives us x. So put in an x, get out an x. It undid the function. And so yes, they're inverses. Let's try that one more time. Are f of x equal to x cubed minus 4 and g of x equal to the cube root of x plus 4 inverses? So again, one thing that I like to do is I like to try it for a specific number first to see if I have to go through the work of showing a general case. You can pick any number you want. I'm just going to pick 1. So f of 1 would be equal to 1 cubed minus 4. In other words, f of 1 is equal to negative 3. So now what I'm going to do, and again, sometimes pictures help. I'm just going to set up my pictures here. I put the number 1 into f, and out came negative 3. What am I going to do now? I'm going to put that into g, and the question is, what do I get out? If I get out 1, then it's possible that they're inverses, and I'll go ahead and show it in the general case. If I don't get out 1, then I know they're not inverses, and I'm just going to stop. All right, so let's put negative 3 into g. So that would be the cube root of negative 3 plus 4. That's the cube root of 1. Oh, that's 1. So I put in a 1 into f and g, and I got out a 1. So it's very possible that these are inverses. So now I have to show that it's true in general. So in general, now what I'm going to do is the same thing. I'm going to put in an x. If I put in an x into f, I get x cubed minus 4. And now I'm going to put that into g, and the question is, what do I get out? Can I show that's equal to x? So let's take a look at function g. So function g is equal to the cube root of x plus 4. And so to evaluate this, I'm going to replace my input right here. And so the question is, let's see if we can figure out what the cube root of, and we're putting in an x cubed minus 4 plus 4 is equal to. Well, you can see that these are going to cancel, and it's just going to be equal to the cube root of x cubed, which is equal to x. So what did we do? We put in an x, applied f, applied g, and got out an x. So yes, these two functions are inverses. So now there's one for you to try. I suggest trying a number first. If it works for a number, then go ahead and show it works for x. If it doesn't work for the number, then you can stop because those functions are not inverses.